Hi there, friends and neighbors. I'm going to now show you a complete example of a results section for a z-test for two proportions, or equivalently, it's mathematically the same thing as a chi-square test for two proportions. Okay, so we're going to be working with a data set from a team called Northern Hackers, and what they hypothesized is that comparing two different age groups, 18 to 30 and over 30, that there would be a difference in their belief about whether or not technology is harmful. So these are the typical components that go into a results section, and for purposes of introductory stats, these are required in your results section. You need to see your descriptive statistics, which for this case would just be sample proportions and sample means, or sample proportions and sample sizes, a graph, and your inferential statistics. Now the inferentials, you'll state HO, H1, and alpha, check your assumptions, get your confidence interval if appropriate, test statistic, degrees of freedom, p-value, make a decision about HO and interpret it, the confidence interval, and finally interpret the whole thing into plain English in a research context. I'm going to start off with stating HO, H1, and alpha because that's sort of what motivates their research. The null hypothesis is that there's no difference between the young group and the old group in terms of their attitude about technology. So the proportion of people who believe that technology is harmful, P, for the younger, I guess we'll say the younger age group, minus that same proportion for the older age group, is equal to 0. There's no difference. Against the alternative, which is that the proportion under younger minus the proportion under older is not equal to 0. Not equal to 0. You can use that exclamation mark to indicate not. Then you choose alpha, which is going to be 0.05 unless you've got a great reason for it not to be. So I'm starting off with that because that sort of motivates everything else. Now the assumption check, actually we are assuming independence, which is achieved by random sampling, but the assumption is that all expected counts are at least 5. That is n times p and n times q is at least 5 for both groups, for all groups. Okay. And of course we assume independence, which is achieved by random sampling. I'm going to go ahead and get the all the goodies now. So I've got the data set already imported and ready to go. Statistical analysis, discrete variables, because it is categorical. We always treat categorical variables as discrete. Then I go to create two-way table and compare two proportions. Fisher's exact. Okay. Now the input variable, the row variable, is going to be age group, of which there are 2. The column variable is the outcome variable, and that's whether tech is harmful. I need the row percentages because that's my descriptive statistics. Choose the chi-square test. That's my hypothesis test. The components are also part of that. The expected frequencies are is the way I will check my assumptions. I need them all to be at least 5. Turn off the Fisher's exact and turn off the continuity correction. Okay. Then you click OK. It gives you everything you need. I'm going to scroll up. First, I want to get my descriptive statistics. They're right here under row percentages. Select that table, right-click, and copy. Come here to my descriptive statistics, right-click, and paste. I want to select this table, change the font to be Courier New. That makes it look nicer. So I can see that in the younger age group, 20% believe in the sample that technology will be harmful, whereas in the older age group, 70% believe in my sample that it will be harmful, that technology is harmful. N is 10 in the older age group, and N is 20 in the younger age group. Okay. Let's see. I'm going to get the graph now, I think. I'll do that. Graphs and tables. Bar graph for frequencies. The variable is going to be tech harmful. That's the outcome variable. And the grouping variable is age group. I'm going to draw them in color, put them side by side, and compare proportions. I click OK. There's my graph. Okay. Now, if you're using Windows or Mac, you can actually just right-click on this and copy it and save it. I'm using Linux, I'm using something else, and so I'm going to need to do it a little bit differently for mine. Specifically, what I'm going to do is copy it into a buffer, paste it into an editor, and select. Just do a rectangular select, cut this, cut, and then go to my Word document, right-click, paste, anchor as text, as character, make it smaller, cut it, and paste it. And that's how I'm going to do it. Now, again, you could just right-click and copy and paste if you've got software that lets you do that. Anyway, it looks like there's a very obvious effect here, and I'm hoping that'll turn up with the inferentials. Let's go see. Now I'm going to go get the confidence interval, test statistic, degrees of freedom, and p-value. So here's that stuff. We don't get a confidence interval with this, and that's okay. We're just going to do the chi-square, 1 degree of freedom, and the p-value. Now, chi-square, in this case, is the same thing as a z-score that you learned about in your textbook, squared. Okay, I'm going to paste that in there. Make a decision. Well, the p-value is less than or equal to alpha, so we reject HO. And interpret what that means in plain English. In plain English, there is a difference between age groups in the proportion, well, I should say, there is sufficient evidence to support the claim that there is a difference between age groups in the proportion who believe technology is harmful. Okay. Now, in looking at the graph, I can see what's actually happening here specifically is that there's a bigger proportion of yes in the older age group. In the older age group, there is a higher proportion, well, there appears to be a higher proportion of belief that technology is harmful. There's one thing I forgot and didn't do. It's my assumption check. I'm going to go ahead and do that now. The assumption is that all expected counts are at least 5. Well, I'm going to go check that now. This actually tells us if the test itself is valid. I'm going to look here at expected counts and copy this table. Right-click, copy, paste, select it, make it Courier new, or just Courier. Anyway, as you can see, not all expected counts are at least 5. You've got 12.7, 7, 6, but then the yes over 30 is too small. The yes over 30 group has expected count less than 5. So we do not meet the assumptions. And therefore, this test is not valid. But we're going to do it anyway because it's a class project. And so if it were valid, then we would say, well, there appears to be evidence that the older age group is more likely to think that technology is harmful. Anyway, that's a complete results section from beginning to end for 2 sample z-test. That's it. Talk to you later.